Hello everyone. I hope everyone is doing well. And today we are here to discuss many of the topics of these three chapters. We are having some basic concepts of chemistry, structure of atom, and redox reactions. Okay, these three are very important chapters in our syllabus. Many of the students find it very difficult to solve the questions from these three chapters, right? For example, if we talk about the first chapter, some basic concepts of chemistry, this chapter, in this particular chapter, we are having the mole concept. We discuss about the mole. We discuss about the stoichiometry, right? And that come again and again in many chapters, not only in the 11th, but also in the 12th, right? So we will be discussing about the mole concept in this particular chapter. Mole we will discuss, and apart from this we will also going to discuss the stoichiometry, and that also we will discuss about the limiting reagent. Okay, the next chapter which we are going to discuss is structure of atom, and after that we will be discussing about the redox reaction. Okay, now in the structure of atom, we will be discussing about the atomic models, right? And in that, the very famous model which is Bohr's model we are going to discuss. Okay, now after that we will be discussing about quantum numbers. Okay, we are having 4 quantum numbers, and about that we will be discussing in a very detail. Apart from this, we will be discussing about electronic configuration. Then we will come to our next chapter, which is redox reaction, and in that oxidation states, and then we will be discussing about the balancing of half reaction. Okay, so these are the things which majorly we are going to cover in this particular lecture. Okay, na? So let's get started with the first one, which is our mole concept, right? Okay, na? So let's first talk about the mole. What is mole, right? है ना? The mole, 1 mole entities, right? So 1 mole is going to represent 6.023 into 10 to the power 23 entities. Okay, the 1 mole is equal to, 1 mole is a number which represent 6.023 into 10 to the power 23 entities. Okay, now for example, let's say you are having 1 mole of electrons, 1 mole of electrons, right? That does mean that 1 mole is equal to 6.023 into 10 to the power 23 electrons. Correct? Okay. Let's take a very familiar example. Let's say you are having 1 mole of pen, right? Now 1 mole is a very bigger number, right? So 1 mole is a very bigger number. We can represent it like 6.023 into 10 to the power 23 pens, right? So this many of pens we are having. I hope it's clear to you what is 1 mole, right? So 1 mole is representing a particular number, right? This number, this number is also called as Avogadro's number. Okay, so 6.023 into 10 to the power 23 is also going to represent a number which is called as Avogadro's number. Okay, okay. Okay, I hope you understood what do you mean by a mole, right? Okay, so here just we have discussed what is mole. Now we will be discussing about the another important topic of today's chapter, which is conversion of mole, right? Conversion of mole into number of particles. So we can convert mole into particles. We can also convert mole into mass. We can also convert the mole into volume, or simultaneously number of particles can be converted into moles, mass can be converted into mole, and volume can also be converted into mole. Okay, so we are going to discuss about these conversions. Okay, so let's talk about the first conversion, which is mole to number of particles, है ना? Mole to number of particles. So let's talk about the first formula. Okay, the first formula is number of moles is equal to number of particles, number of particles by Avogadro's number. Avogadro's number, right? That is 6.023 into 10 to the power 20. Okay. Chali, so let's also write down this formula in the short form. Number of moles is equal to number of particles divided by Avogadro's number, right? So from this formula we can calculate the number of moles. Okay. For example, let's say we are having, for example, let's say we are having 12.046 into 10 to the power 40 electrons, right? These many of electrons we have, and now we have to calculate the number of moles for the electrons, right? So how we will be calculating the number of moles? Number of moles will be equal to the number of particles. Number of particles are 12.046 into 10 to the power 40 divided by Avogadro number. Avogadro number we have is 6.023 into 10 to the power 20. Okay. Now you can cancel out the things, right? 12.046 by 6.023, that is 2 times, and 10 to the power 40 by 10 to the power 23, that will be 10 to the power 17, right? The number of moles of electrons, number of moles of electron will be equal to 2 into 10 to the power 17. Okay, so I hope this formula is clear to everyone how we are going to calculate the number of moles. Okay, chaliye discuss now let's discuss the next interconversion, which is mole to mass conversion. Okay na? So again we are having the formula number of moles is equal to mass of substance in gram, mass of substance in gram divided by molar mass, molar mass. Okay, so this is the formula. In the short form we can write it, number of moles is equal to mass of substance in gram divided by molar mass of a substance. Okay, so before coming to this moles is equal to mass upon molar mass, here one thing came into the picture which is called as molar mass. Okay, so let's talk about the molar mass first. है ना, what is the molar mass? Okay, so let's have a quick discussion about the molar mass. Okay, molar mass is generally represented by capital M. Okay, so let's take the example. If we talk about the H2O, the molar mass of H2O will be equal to, देखिए 2 into 1, hydrogen is having 1 gram per mole is the molar mass, oxygen is having 16, so you can get 18 gram per mole, right? Let's talk about the H2SO4. For the H2SO4, if we calculate the molar mass, it will be equal to 2 into 1 plus sulfur. Sulfur is having 32 plus 4 into 16, correct? So here we will be getting 98 gram per mole. Okay, let's talk about the glucose C6H12O6, right? So this is our glucose. For the glucose we have this formula, and if we talk about the molar mass of this particular glucose, you can easily calculate, so you can multiply the things, 6 into 12 plus 12 into 1 plus 6 into 16, right? So from here we will be getting 180 gram per mole. Okay, so this is how we calculate the molar mass. Okay, so molar mass we can calculate like this. Okay, chali, okay. Unit of the molar mass you can see in all the answers, which is gram per mole. ठीक है, तो यूनिट ऑफ द मोलर मास विल बी इक्वल टू ग्राम पर मोल, ठीक है। नाउ लेट्स कम टू द this formula which we were discussing, ठीक है ना। तो number of moles is equal to mass upon molar mass, ठीक है। तो let's take a very small example in this. Let's say we are having we are having we are having 22 gram of CO2 present present in a sample, ठीक है। तो 22 ग्राम ऑफ CO2 present in a sample, calculate the number of moles, calculate the number of moles calculate the number of moles of CO2, ठीक है। चलो तो लेट्स डू इट। तो number of moles of CO2 will be equal to mass of CO2 mass of CO2 by molar mass of CO2. Mass of CO2 we already know, that is 22 gram, divided by molar mass of CO2. When you will calculate the molar mass, carbon is 12 plus 2 into 16, so you will be getting 44 gram per mole, ठीक है। तो here you have 22 by 44 gram, and here gram per mole, so gram per mole will be reversed and you will be getting this situation. Right now we can cancel out the things, okay, this is 22 and 44, they will be cancelled by 2 times. Now gram and gram is cancelled, so here you will be getting the half mole. So half mole of CO2 we have, okay. So I hope this formula is clear to everyone, because uh, after these formula we will be doing some advanced level questions, NEET level questions. So understanding these formula is very much needed, ठीक है। चलिए next let's talk about the next one, which is called as mole to volume conversion, है ना। ठीक है, तो next formula is moles to volume conversion, moles to volume conversion, ठीक है। चलिए तो let's talk about the third formula, moles to volume conversion. So here we have number of moles is equal to number of moles is equal to volume of gas at STP ATM divided by 22.4, ठीक है। तो वॉल्यूम ऑफ गैस एट STP in liter divided by 22.4. The short form we can write number of moles is equal to volume of gas in liter divided by 22.4. So from this formula we can easily calculate the number of moles of the gas, ठीक है, assuming it is ideal gas. चलिए okay, now let's talk about one of the example. To understand this formula, then we will proceed for the other examples. So the question or example we have in front of us is calculate the number of moles the number of moles calculate the number of moles present in 5.6 liter of dioxygen gas, ठीक है। तो we can use the formula moles of oxygen gas will be volume of O2 gas divided by 22.4, ठीक है। तो it will be very simple to calculate, just you put the data and you will be getting the answer, correct। So when you solve this you can easily get 1 by 4 moles of dioxygen. Okay, so I hope these formulas are clear to everyone. Now we can move back. Now we can move forward to our next a good level of questions. So let's talk about them, let's discuss about them. Okay, so this is the question in front of us, and what they are asking, we have to understand it first. The question is, what amount of dioxygen, right, in grams? So basically they are asking about what amount of dioxygen, means they are asking about the mass of O2, correct, contain contain contains 1.8 into 10 to the power 22 molecules. So here you have given the number of particles of dioxygen, and they were asking what is the mass of these many of particles. So we can calculate definitely. Before calculating this thing, just let's talk about the formula which we have discussed is number of moles. We have seen many formula. The number of moles is equal to number of particles by Avogadro number. One more formula which we saw was mass upon molar mass, and the other formula which we saw was volume of gas divided by 22.4. Okay, so here we have given the number of particles, from that we have to calculate the mass, so we are going to use this formula. Okay, so we are going to use these two so that we can easily calculate the mass. Now let's talk about that. So number of particles of O2 by Avogadro number will be equal to mass of O2 molecules divided by molar mass of O2. So number of O2 particles which is given to us, that is 1.8 into 10 to the power 22 divided by Avogadro number we already know. So in the round figure we can put 6 into 10 to the power 23 is equal to mass we have to calculate, and molar mass of O2, right? Molar mass of O2 16 into 2, that will be 30. ठीक है, चलो ओके, तो लेट्स सॉल्व दिस. अब क्या आने वाला है, तो लेट्स टॉक अबाउट इट, ठीक है ना. तो लेट्स रिमूव द डेसिमल. सो हियर यू विल बी गेटिंग दी 10, ठीक है. 18 by 6 will be 3, and this part will become 10 to the power 2, ठीक है. So we will be having mass of O2, will be equal to 3, and this side we have 32, so 32 will go this side, so 3 into 32 by 10 to the power 2. 10 to the power 2 is 100. So when we solve this, we will be getting 96 by 100, which will be definitely 0.960 gram, right? So this is the mass of this many of oxygen particles, right? Actually, okay, so now you can tell me the answer option, which option is correct. Option number 2 is correct, right? Okay, so I hope it is clear to everyone how we have calculated the things, right? Okay, fine, let's move to the another example. Okay, so question is saying what volume in liter is occupied by 60 gram of ethane. I hope you remember the formula of ethane, which is C2H6. So what volume, they are asking about the volume occupied by ethane, volume they are asking, correct? And what they have given is 60 gram of ethane. 60 gram of ethane, the mass of ethane they have given is 60. Chali, okay, so here again we are going to use the formula of moles, in which we have number of moles is equal to the number of particles by Avogadro number, mass upon molar mass, and volume of gas by 22.4. Okay, so what is being given to us? Volume we have given to us. What they are asking is mass they are asking, right? So we can use the last two formula. So here we have mass of ethane, and I'm directly writing mass of ethane divided by molar mass of ethane is equal to volume of ethane divided by 22.4. Correct. So mass is given to us, which is 60. Now molar mass of ethane, so 2 into 12, 24, 24 plus 6, 30. So 30 gram per mole is the molar mass of ethane, is equal to volume we have to calculate divided by 22.4. So now I hope it is very much clear how to solve this, right? It is a very easy equation. So 60 by 30, it will be 2. So volume of ethane will be equal to 2 into 22.4, that will be equal to 44.8 liter. Okay, so 44.8 liter we will be having the volume. Okay, great. Chali, okay, now let's talk about the next example in front of us, which is this one. Okay, so I hope you can read the question. In this given question, if 3.01 into 10 to the power 20 molecules are removed, okay, okay, so we are having these many of particles removed from 98 milligram of H2SO4, then number of moles of H2SO4 left in the container they are going to ask. Okay, so let's talk about this question. So we have discussed about this question, what is already provided to us, and they are asking the number of moles of H2SO4 left in the container. So initially we had 98 milligram 98 milligram of H2SO4. Now from this 3.01 into 10 to the power 20 molecules of H2SO4 are removed. Then they are asking what is left. How many moles of H2SO4 are left in this particular container? They're asking. Okay, so we can calculate. So now just I am going to write the equation for this. The number of H2SO4 left will be equal to number of moles of H2SO4 which were already present minus number of moles of H2SO4 removed. ठीक है, तो देखिए number of moles of H2SO4 already present. So already present, so we have 98 milligram of H2SO4. From this we can calculate the number of moles. The number of moles will be equal to mass. Mass is 98 milligram. So 98 milligram will be equal to 98 into 10 to the power minus 3 gram. We have to put the mass. Put the mass in the gram. Divided by molar mass of H2SO4. So in today's session only we have calculated the molar mass of H2SO4, right? I hope you remember the value of this molar mass of H2SO4. Correct? Chalo, okay. So this was 98 gram per mole. ठीक है, minus number of moles of H2SO4 removed. So this many of particles 3.01 into 10 to the power 20, these many of H2SO4 particles are removed. Now we can calculate the moles from it. So we are having 3.01 into 10 to the power 20 H2SO4 molecules divided by Avogadro number. Avogadro number is 6.02 into 10 to the power 20. Now we have to solve this, right? So 98 and 98 cancelled. So we will be having 1 into 10 to the power minus 3 moles, which is already available, minus 3.01 and 6.02. They will be cancelled here too, and here 10 to the power 20 and 10 to the power 23, that will be 10 to the power 3. So here we have 1 by 2. 1 by 2 I can write as 0.5 into 10 to the power 3. Now 1 minus 0.5 will be equal to 0.5 into 10 to the power minus 3. Okay, so this many of H2SO4 left in the container. The answer is option number answer is option number 3. So this is how we can calculate the things whatever being asked for, right? Chali, okay. So now let's come to our next topic, that is the stoichiometry. Okay, the stoichiometry. This is what we are going to discuss now. Stoichiometry. What do you mean by stoichiometry? The stoichiometry, है ना? In this, what we do? Suppose we are having a particular reaction. Let's say a hypothetical reaction which is balanced chemical equation. Small a, small b, capital B. Sorry, small a, capital A plus small b, capital B. Small c, capital C plus small d, capital D. Right? And this you can see capital A, capital B are the reactants. Capital C, capital D are products. Right? Here, when we look at the small a, small b, small c, and small d, they are stoichiometric coefficient. So small a, small b, small c, and small d are stoichiometry coefficient. Okay, they are stoichiometry coefficient. Okay, so stoichiometry means basically the calculation of number of moles. Stoichiometry means basically the calculation of number of moles of reactants or products, calculation of mass of reactants and products, calculation of volume of reactants and products. This is what we are going to do in this stoichiometry session, right? Chaliye, now how we are going to calculate, that is what we are going to discuss. So we are having this equation, and in this particular, for this particular equation, uh, whenever we calculate the things, make sure that you have the balanced chemical equation, we have the balanced chemical reaction, correct? Okay, apart from this, better we don't have the limiting reagent, है ना? Better we don't have the limiting reagent. चलिए आइए, तो now let's talk about how we are going to calculate the moles of the reactants and products, how we are going to calculate the mass, how we are going to calculate the volume. That is what we are going to discuss now. In order to calculate the number of moles, we are going to use the equation, and that equation is number of moles of A divided by stoichiometry coefficient of A is equal to moles of B divided by stoichiometry coefficient of B is equal to moles of C by stoichiometry coefficient of C is equal to moles of D by stoichiometry coefficient of capital D. So from this equation we can write moles of A, that will be given in the question, divided by stoichiometry coefficient of A, which is small a, will be equal to, we are having the moles of B divided by stoichiometry coefficient of capital B, which is going to be small b, is equal to moles of C. The moles of C maybe this will be given in the question, or you have to calculate it, divided by the stoichiometry coefficient. The stoichiometry coefficient is C. Now let's talk about the moles of D. Moles of D divided by stoichiometry coefficient of D, which is small d, right? Okay, so this is the equation, or this is the formula, you can say, we are going to use to calculate the number of moles or mass or volume. Let's apply this to this particular equation. So we are having this particular equation, and let me rewrite it. We are having the 1N2 plus 3H2 gas converting into 2NH3 gas, right? So for this equation, we can write down the formula like this. And how we are going to write down the formula? Moles of N2, okay, moles of N2 divided by stoichiometric coefficient. Stoichiometric coefficient is 1 is equal to moles of hydrogen divided by stoichiometric coefficient, which is 3, is equal to moles of ammonia divided by stoichiometric coefficient, which is going to be, right? So I hope you understood how we are going to write down the formula, and based upon the formula we can do the question, right? Okay, so let's do some of the questions on this particular stoichiometry. Okay na? Chali, okay, so this is what we have as a question. You can read the question, you can take 1 to 2 minutes. So I hope you have read this question, uh, right? So let's talk about this question, how we are going to solve this. Okay. How many moles of potassium chlorate? How many moles of potassium chlorate? Okay. So this is our potassium chlorate. Need to be. So we have been asked about the moles of potassium chlorate. Heated, heated to produce 11.2 liter oxygen at STP. 11.2 liter at STP. Okay na? So let's talk about this. So first of all, when you look at the oxygen, so for the oxygen we have given the volume. We can easily calculate the number of moles of oxygen, which is moles of oxygen, volume of oxygen by 22.4. So volume of oxygen is given to us, which is 11.2 divided by 22. Okay, so it will be equal to 1 by 2. So we have given 1 by 2 moles of oxygen. Okay. Now for this particular equation we can apply our formula. So for this equation we can apply moles of KClO3 by stoichiometry. Stoichiometric coefficient is 1 is equal to, we have been asked the moles of KCl3 we can calculate, and what we have given is oxygen. So let's take only the oxygen. We can also put the formula for the KCl as well, but let's write it for the oxygen. So we are having moles of oxygen by stoichiometric coefficient of oxygen. Stoichiometric coefficient of oxygen is 3 by 2. Okay. So moles of KClO3 will be equal to moles of O2 we have calculated, which is 1 by 2, and here we have 3 by 2. Okay. Now let's simplify this equation. So 1 by 2 into this 3 by 2 will be reversed, so it will be 2 by 3. Okay. 2 and 2 will be cancelled. So ultimately we got the moles of potassium chlorate needed is 1 by 3, 1 by 3, right? So it's easy to calculate, right? So option number B is correct. चलिए ओके, ठीक है, ठीक है, okay, fine. Now let's talk about the next concept, which is which is limiting reagent, है ना? So next we are going to talk about the concept which is called as limiting reagent. Limiting reagent, limiting, limiting means less, right? So limiting reagent is the reactant which is present in a less quantity, the reactant which is present in a less quantity relatively, relatively, right, है ना? So we are comparing, let's say we are comparing two reactants, and if their ratio is not as per the stoichiometry, and if something is less, that is known as limiting reagent, ठीक है? Limiting reagent will be consumed first, not last, will be consumed first in a chemical reaction, in a chemical reaction, ठीक है? चलिए, तो now let's talk about how to calculate this limiting reagent. How to calculate this limiting reagent we are going to discuss, ठीक है? तो let's say मान लीजिए you are having the equation small a capital A plus small b capital B converting into the product, ठीक है? Converting into the product, converting into the products, right? Now in order to know which one is going to be the limiting reagent, what we are going to do is we are going to calculate the ratio which is called as limiting reagent ratio. So we are going to calculate the limiting reagent ratio, which is going to be moles by stoichiometry coefficient, moles by stoichiometry coefficient, moles by stoichiometry coefficient, ठीक है? So we let's apply for the equation. We are having the moles of A divided by stoichiometry coefficient. Stoichiometry coefficient is given, which is small, and we have also calculated, we can also calculate it for the B, so that will be moles of B divided by stoichiometry coefficient. Stoichiometry coefficient is B, ठीक है? तो we have calculated the limiting reagent ratio, and when we compare both of these value, when we compare both of these value, and let's say this one is coming less, if this one value is less, then we will be considering A as our limiting reagent, and if if this one is less, the another one, the second one is going to be more, and the one for which it is more is called as excess reagent, excess reagent, excess reagent, ठीक है? तो we will be having the limiting reagent and another one will be the excess reagent, ठीक है? तो this is how we are going to calculate the, we are going to identify the limiting reagent based upon the limiting reagent ratio. So moles upon stoichiometric coefficient if we will be doing, and if the value is less comparative to the other values, then that particular reactant will be considered as limiting reagent. चलिए, तो let's talk about one more important concept in this, which is a very good note which you have to remember, that is product, product should be made, product should be made as per, as per product should be made as per limiting reagent, limiting reagent, limiting reagent will be deciding the amount of product formed, not the excess reagent, not the excess reagent. limiting reagent, limiting reagent is going to decide how much product is going to be made, right? Because this is a very important note which you must remember to solve the questions having the limiting reagent. Okay, so let's talk about the examples in this. First we'll talk about the examples, and then we will be doing the few more questions on that. So first let's identify the limiting reagent, है ना? So we are having this equation in front of you, and in this we have to calculate, or we have to identify which one is the limiting reagent. Okay, so this is the equation. 10 moles of A is given to you, 10 moles of B is also given to you in this reaction, which is a limiting reagent. Okay, so let's identify the limiting reagent. Okay, so A is there, so let's calculate the limiting reagent ratio, that is moles by stoichiometric coefficient, moles by stoichiometric coefficient, correct? So for the A we can calculate, moles are given to you in the question, which is 10, and stoichiometric coefficient is 1, right? For the B, when we calculate the moles by stoichiometric coefficient, the number of moles are 10 divided by stoichiometric coefficient. Stoichiometric coefficient is what? Now here the value is 10, here the value is what? 2. Now you can tell me which value is less, right? You can compare. It is very easy to see that this value is less. If this value is less, then definitely B is going to be our limiting reagent. And which value is more? 10. This value is more, so A will be considered as what? Excess reagent, correct? Okay, so this is how we can get to know which one is limiting reagent and which one is going to be our excess reagent. Now the thing is, the products will be decided based upon the limiting reagent. So limiting reagent will be deciding the amount of product formed. Okay, so now let's do one question on this. Okay, so we are having this question in front of us, and let's talk about it. So what the question is, when 22.4 liter of H2 gas is mixed. Okay, so we have given the volume of H2 gas, which is 22.4, and definitely from this we can calculate the moles of H2. Moles of H2 is 22.4 by 22.4, that is going to be 1 mole, correct? Now the another thing is given to us, which is mixed with 11.2 liter of Cl2 gas. The volume of Cl2 gas is 11.2 liter. Now we can easily calculate the moles, right? Moles is 11.2 liter by 22.4, which is half mole. Half mole बोले तो 0.5 moles. ठीक है? Each at STP, they're asking the moles of HCl formed is equal to. Okay, so they are asking about the moles of HCl formed. Okay, so let's talk about it. Let's discuss about this. So first we have to write down the equation, and then we can proceed for the question. So we are having H2 gas plus Cl2 gas converting into 2HCl gas. Okay, now in this, let's calculate the limiting reagent ratio. Let's calculate the limiting reagent ratio. The limiting reagent ratio will be moles by stoichiometric coefficient. So here moles of hydrogen is given to us, which is 1. Stoichiometric coefficient you can clearly see, which is 1 again. Now Cl2, for the Cl2 moles are given to us, which is 0.5 moles, divided by stoichiometric coefficient. So here you can clearly see which one is less, right? Which one is going to be less? This one is going to be less. If it is a less, definitely Cl2 is going to be our limiting reagent. Cl2 is going to be our limiting reagent, and as I told you, the limiting reagent will decide the amount of production. Okay, so let's discuss about this. अब देखिए, from the stoichiometry you can see 1 mole of Cl2 is producing 2 moles. 1 mole of Cl2 is producing 2 moles. So 0.5 moles will be producing 2 into 0.5, which is equal to 1 mole. So there will be the production of 1 mole of HCl. 1 mole of HCl. Okay. So answer is option number D. Okay, the answer is option number D. Okay. So this is how we have done the important questions in this particular chapter. Some basic concepts of chemistry we have discussed, how to calculate the moles, how to do the questions in the stoichiometry, and what is the limiting reagent, how to do the questions on the limiting reagent, right? So this is what we have discussed about this chapter. Now we are going to talk about our next chapter, which is called as structure of atom, है ना? So structure of atom is the chapter which we are going to discuss, right? In this, every year the question is coming from the Bohr's model, right? The question is coming from the Bohr model, and we are going to discuss this Bohr model. Okay, and when we calculate the things in the Bohr model, in which we have the important things which are velocity. So we will be calculating the velocity, we will be calculating the radius, we will also be calculating the energy of electron present. Okay, so now let's talk about the formula of each one. So velocity of electron, है ना? जैसे मान लीजिए you are having the nucleus, and around the nucleus we are having the electron. Around the nucleus we are having the electron. ठीक है, we are also having other shells as well. So in them also there can be the electron, correct? So here you see the distance of the electron from the nucleus, the radius. So what we are going to calculate? We are going to calculate the radius part. The velocity of electron, so velocity of electron we are going to calculate, and this particular electron will be having the energy, this particular electron will be having the kinetic energy, it will be having the potential energy, it will be having the total energy. So these three types of energy also we are going to discuss. Okay, so let's talk about them, let's discuss about them: velocity, radius, and energy. So first we are going to talk about the velocity phenomena, right? So let's have the discussion about the velocity, right? So first formula is about the velocity. So when we talk about the formula of velocity, velocity will be equal to 2.18 into 10 to the power 6 z upon n meter per second. Z upon n meter per second. This is the formula of velocity of electron in nth shell. Now z is our atomic number, n is the shell in which electron is revolving. Now I'm going to modify this formula. So velocity of electron in the nth shell will be equal to V naught into z upon n. This formula can also be used. ठीक. Now here what is V naught? V naught is basically velocity of electron in first shell or first orbit, first Bohr orbit of hydrogen atom, of hydrogen atom. ठीक है, चलिए, तो V naught is the velocity of electron in first Bohr orbit of hydrogen atom. Now let's talk about the next thing in this, which is from this particular formula we can also write down, that is V2 by V1. V2 by V1 will be equal to Z2 by Z1 multiplied with N1 by N2, right? So this formula also can be used to calculate the things. चलिए, so this is about the velocity, है ना? This is about the velocity part. Now let's talk about the next thing which we are going to discuss is the radius part, है ना? Radius part. So radius r is equal to 0.529 n square by z. 0.529 n square by z angstrom. So radius is equal to 0.529 n square by z, and the unit of radius we are going to put in angstrom. Radius of the nth shell will be equal to r naught into n square by z. We can also use this particular formula, right? In this particular formula, r naught is radius of radius of radius of first Bohr orbit, of hydrogen atom. ठीक है? So r naught is the radius of first Bohr orbit of hydrogen atom. चलिए, from this particular formula we can also write the another ratio, which is r2 by r1. R2 by r1 will be equal to n2 by n1, and the square of that multiplied with z1 upon z2. ठीक है? So we can also use this formula. ठीक है ना? चलिए, okay, so this is what we discuss about the velocity as well as radius. Now we are going to talk about the energy part. We will be discussing about total energy, potential energy, and also we are going to discuss about kinetic energy. So let's talk about that part also. So kinetic energy, total energy, and potential energy. Okay. So first we are going to talk about total energy. The total energy is denoted by En. En is equal to minus 13.6 Z square upon N square. Minus 13.6 Z square upon N square electron volt per atom. ठीक है? तो fine. Now let's talk further. So En will be equal to, you can also write E naught into Z square upon N square. Here again E naught is energy of total energy of electron in first Bohr orbit of, है ना? Total energy of electron in first Bohr orbit of hydrogen atom. ठीक है? चलिए, from this we can also write one more ratio, which is E2 by E1, will be equal to Z2 by Z1 multiplied with N1 by N2 and the whole square. Okay? So this is how we are going to write the things. Okay? Chali, okay. Now we are going to do the questions based upon these formulas, so they will be much clear to you. So let's come to our formula. Let's come to our questions. So this is the question in front of us. So just you read it for 1 minute and then we will be solving this question. Okay, so I hope you have read this question. The question is saying if the velocity of electron in first orbit of hydrogen, velocity of electron in first orbit of hydrogen is what? V. What will be the velocity of electron? What will be the velocity of electron in third orbit of lithium plus 2? ठीक है, so they are asking the velocity in, they are asking the velocity in third orbit of lithium plus 2. This is what they are asking. ठीक है, so here third orbit, so third orbit, so n will be equal to what? 3. The third orbit, so n will be equal to what? 3. ठीक है, and lithium plus 2, for the lithium plus 2 z will be equal to what? Z will be equal to, atomic number will be equal to again 3. So let's solve this question. Okay, now here we all know that Vn is equal to V naught Z upon N. So V naught value is given to you, that is capital V. Atomic number is given to you, which is 3, and the shell is also given to you, that is 3. Okay, so velocity of electron in third shell of lithium plus 2 is going to be 3 and 3 will be cancelled, so answer will be, so option number A is the correct. Option number A is going to be the correct. चलिए, okay, ठीक है, so A is the correct one. Now let's come to our next question, which is this one. So this question is saying if the radius of second Bohr orbit, if the radius of second Bohr orbit of the helium plus, for the helium plus, we have the atomic number is 2, is 105.8 picometers. ठीक है, what is the radius of third Bohr orbit? What is the radius of third Bohr orbit of lithium plus 2? For the lithium plus 2, the atomic number is going to be 3. Correct. Chali, okay, so this is what we have to discuss. We have to calculate the radius of third Bohr orbit of lithium plus. ठीक है, चलिए, तो we can calculate, let's make it as a R2, है ना, let's consider it as a R2, and here R1 is given to you, R1 is equal to 105.8 picometer. चलिए, तो we are going to use the formula R2 by R1. R2 by R1 will be equal to N2 by N1 and the square of that multiplied with Z1 by Z2. ठीक है, चलिए, okay, so R2 we have to calculate, divide by R1. R1 is what? 105.8. ठीक है, चलिए, N2 is 3 by N1. N1 is how much? N1 is 2 and the square of that multiplied with Z1. Z1 is 2 and by 2. ठीक है, चलिए, तो let's solve this. So from here we will be getting the R2 is equal to 105.8 multiplied with This will be 3 by 3, 2 by 2 into 2 by 3. Now you can cancel out the things. 3 and 3 is cancelled and 2 and 2 is cancelled. Okay. So when you will solve this 105.8 into 3 by 2, you will be getting 158.7 pico meter. Okay. चलिए तो R2 is 158.7 pico meter. So answer is our option number. ठीक है. चलिए okay. Next question in front of us is this one. First you read out the question. The question is the energy of electron in the ground state for helium plus is minus x joule. ठीक है. So you have given the E1 which is minus x joule for n is equal to n1 is equal to 1, and for the helium plus atomic number is 2. Then they are asking then that for an electron in n is equal to 2, so n2 is equal to 2 for beryllium plus 3. For the beryllium plus 3, the atomic number will be equal to 4. So for this we have to calculate the energy. Okay. So just now we saw the formula and we are going to use the formula which are E2 by E1, which are going to be E2 by E1. E2 by E1 will be equal to E2 by E1 will be equal to Z2 by Z1 and N1 by N2 and the whole square of that. ठीक है. So E2 is given to you. E2 has to be calculated. E1 is minus x is equal to Z2. Z2 is 4 by Z1. Z1 is 2. Correct. Multiplied with N1. N1 is 1 and N2. N2 was N2. So N2 is 4. Correct. ठीक है. चलिए okay. So when you will solve this, you will be getting E2 is equal to, so here let's cancel out the things. 4 and 4 will be cancelled. ठीक है ना. ठीक है. 4 and 4 will be cancelled. So here you will be getting, okay, let me check this formula. There's something Z2 we have put. Z2 is 4, Z1 is 2, N1 is 1. Okay. N2 is 2 है ना. So we have made a little mistake, just now we can correct it. Okay. So here N2 is 2, right? So N2 is 2, so we have to put here the 2. Okay. So 4 here and 2 here, right? Okay. So now we can cancel out the things. So 4 by 2 and also 2, so they will be cancelled, and finally we will be getting E2 is equal to minus 6. Okay. So answer is going to be the option number. Okay. I hope it is clear to you, right? चलिए, तो answer is going to be option number 3. चलिए, okay. Now let's come to our next topics, which are quantum numbers. Okay. Quantum numbers. So let's talk about these quantum numbers. What are the quantum numbers? है ना. So quantum number. मान लीजिए, let's say you are living in India. In India, you are living in Karnataka. ठीक है. The Karnataka, you are living in Bengaluru. ठीक है. The Karnataka, you are living in Bengaluru. And in the Bengaluru, you are living in Banaswadi. ठीक है. Banaswadi. ठीक है. If I have to come to the Banaswadi from, let's say, from Dubai, however, there is a, you know there is a very critical situation at that place for now, but still, let's say from Dubai I want to come to the Banaswadi. So first I will come to the India, then Karnataka, then Bengaluru, then Banaswadi, right? So my location can be decided based upon this structure, based upon this hierarchy, correct? So similarly, if we want to know the position of electron, if we want to know the position of electron, then if we want to know the position of electron, then we are going to use the quantum number. Quantum numbers are principal quantum number, azimuthal quantum number, magnetic quantum number, and spin quantum number. So let's first talk about the shell, है ना? So first quantum number, principal quantum number, is going to tell you about shell or orbit, shell or orbit, ठीक है? Now let's talk about the next thing. Next is our subshell. So in the shell we will be having subshell or sub energy level. We will be having sub energy level. Now in the subshell or sub energy level, we will be having the orbitals. We will be having what? Orbital. Okay. And in the orbital, who will be living? In the orbital, we will be having what? Electron. Right? So in order to know the position or location, in order to know the position or location of electron, we require the principal quantum number, which is going to represent the shell. We require the, again, next quantum number, which is azimuthal quantum number L. In order to know the orbital, we require the next quantum number, which is M, magnetic quantum number, right? And we are also having the fourth quantum number, which tell you about the spin of electron, which we have separately defined. Okay, and that definitely we are going to discuss. So let's first start with the first quantum number, which is called as principal quantum number. So let's talk about the principal quantum number. Okay, the first quantum number which we have is the principal quantum number. So principal quantum number, okay, small n, okay. What this is going to represent? This principal quantum number is going to represent the energy level, energy level, ठीक है, energy level. They are going to represent the energy level, size of orbit, ठीक है. So for example, let's talk about, let's say we are having the nucleus, we are having the first shell n is equal to 1, then we are having the next shell which is n is equal to 2, then we are having the n is equal to 3. So n is equal to 1, n is equal to 2, and then we are having the n is equal to 3. So we are having the different shell. Okay, this different shell, this different orbit, this different energy levels are denoted by a principal quantum number. They are denoted by principal quantum number. Okay, the name of the first shell is K shell. Name of the second shell is L shell. Name of the third shell is N shell, and so on. K L M, sorry, M, M shell. K L M N O P Q, and so on. Right? Okay. Now, how they are going to represent the energy? They are going to represent the energy levels. But we just saw the formula. En is equal to minus 13.6 z square upon n square, right? They are going to represent the energy level. They are going to represent the size. We have also seen the size. R is equal to 52.9 n square by z, right? So they are also telling you about the size. They are also telling you, they are telling you about the radius. and radius is also representing the size. Lower will be the radius, lower will be the size of energy level. Higher will be the radius, higher will be the size of particular shell. Right? So principal quantum number is a very simple quantum number which is telling you about the energy level, which is telling you about the shell. Now let's talk about the next quantum number, which is called as azimuthal quantum number. Azimuthal quantum number. Azimuthal quantum number, which is represented by small l, which is represented by small l. ठीक है ना? तो azimuthal quantum number. ठीक है? So let's talk about this. This is going to represent sub energy level. This is going to represent what? Sub energy level. ठीक है? Sub energy level बोल दीजिए, या फिर you can also tell you, they will tell you about the sub shell. ठीक है? Sub shell. Okay. They are also going to tell you the shape of subshell, or say a subshell shape of subshell or orbitals. ठीक है? What is the shape? It is going to be told by the azimuthal quantum number. The value of azimuthal quantum number, the value of azimuthal quantum number start from 0 and it ends at n minus 1. It ends at n minus 1. So let's talk about this. Let's say we are having n is equal to 4. Okay? If we are having n is equal to 4, now L will lies, L value will be from 0 to n minus 1, means 0 to 4 minus 1. So 0 to 4 minus 1, so 0 to 4 minus 1 is going to be 0 to 3. So L values will be 0, L value will be 1, L value will be 2, and L value is going to be correct. ठीक है? अब this L value 0 represent the S subshell. It represent the S subshell. L is equal to 1 value represent P subshell. L is equal to 2 value represent D subshell. L is equal to 3 represent F subshell. ठीक है? Correct. चलिए, so this is how they are going to represent. So L is equal to 0, S, 1, P, 2, D. L is equal to 3 is representing F. L is equal to 4, so S, P, D, F, G, H, I, and so on. Right? चलिए, okay. Now, if we talk about S subshell, it will be having a particular shape. Shape we are going to talk about. So shape of S will be spherical. S will be spherical. Okay. P will be dumbbell. Okay. Next D will be having the double dumbbell. ठीक. चलिए, okay. F will be having a complicated shape. चलिए, so let's talk about the next quantum number which we are going to discuss is the magnetic quantum number. Magnetic quantum number. Magnetic quantum number, which is represented by magnetic quantum number, which is going to be represented by small m, which will be represented by small m. ठीक है? So magnetic quantum number which is represented by a small m. It is going to tell you the orientation. This is going to tell you the orientation of orbitals. Orientation of orbitals. Orientation of orbital. Orbital means electron cloud. Electron cloud. Orientation of orbital or orientation of electron cloud. So this quantum number is going to represent orientation of orbital or orientation of electron cloud in a particular direction. In a particular direction. Okay. So let's talk about it. The value of the value of the value of m the value of m magnetic quantum number will be from minus L to plus L. The value of m will be from minus L to plus L, including 0. Including 0. Okay, now let's talk about it. Let's suppose if we are having the L value 0, if we are having L value 0, then m value will also be 0. If L value is 0, then m value is also going to be 0. Okay. Now if we talk about the L value, let's say L value is 1. So m value will be from minus 1 to plus 1. So minus 1 to plus 1. So minus 1 0 plus 1. Okay. Minus 1 0 and plus 1. Okay. So now here how many values you see here? How many values you see? So 1 2 3. Okay. 1 2 3. In these three value, if you have the three value, you will be having the three orbitals. You will be having what? Three orbitals. So if you are having the three values, you will be having the three orbitals like this. Okay. Now here the minus 1 value can represent px or py. Minus 1 value can represent px or py. The plus 1 value can also represent px or py. However, there is a fixed value for the pz, and for the pz we have the fixed value of m, which is equal to 0. So 0 is representing the pz, m value 0 is representing the pz, or for the pz m value is going to be 0. That is fixed. That is what fixed. Okay. This thing you can remember. Okay. So now we are having the px, py and pz. So let's talk about this px, py and pz. So let's suppose if we are having this x direction, in this x direction, uh, and let's say this is y direction and this is our z direction. Okay. So x direction px, we are discussing about the px. So for the px, electron density will be on the x direction. Electron density will be on the x direction. Now if we talk about the py, if we talk about the py, for the py, the electron density will be on the y-axis. And if we talk about the pz, for the pz, electron density will be on the z axis. Electron density will be on the z axis. Okay. Now let's also talk about the next thing, which is about L is equal to 2. L is equal to 2 means d sub shell. M value will be from minus L to plus L. So minus 2 to plus 2. So minus 2, minus 1, 0, plus 1, plus. Okay. So here we will be having different values. How many values? You can clearly see the number of values are 5. So each one is representing different orbital. Okay. Let's say minus 2 is representing dxy, minus 1 is representing dyz, plus 1 is representing plus 1 is representing dxz, plus 2 is representing dx square minus y square. ठीक है. Now let's talk about the zero value. 0 is specifically given to dz square. 0 is specifically given to dz square. ठीक है. चलिए, so now let's also talk about their structures. Let's also talk about their structure. So first we are going to discuss about dxy. ठीक है. तो dxy, the structure of dxy will be, let's say this is x, this is y. Electron density, electron cloud is present in between the axis. Electron clouds are present in between the axis for the dxy. Now let's talk about the dyz. For the dyz, electron density will be present in between y and z direction. Now let's talk about dxz. ठीक है. So here electron densities are present in between the axes. Electron densities are present in between the axes. Let's also talk about the dx square minus y square. Structure of dx square minus y square is like this: x direction, y direction. For this electron density, is present on the both of the axes, x and y. So for the dx square minus y square, electron density is present on x axis as well as y axis. ठीक है. dz square. For the dz square, we are having this z direction, x direction, y direction. ठीक है. Now for the dz square, electron density will be on the z axis. Electron density will be on the z axis. Electron density will be on the z axis. However, there is a small ring. Which is present on the xy plane that will also be containing the electrons. Okay, so there is a ring present in the xy plane that will be also having some electron density. Okay, major electron density will be present on the z axis. Chali, okay, so this is what we have seen magnetic quantum number. Let's talk about the last quantum number which we have is the spin quantum number. Last quantum number is spin quantum number, which is represented by small s. So spin quantum number, ठीक है ना. The spin quantum number we have, let's say we are having the orbital. In the orbital we are having the two electrons. ठीक है. They are having the opposite spin. Let's talk about the example of earth. Earth is rotating around the sun, that we all know. It is also revolving on its own axis, that is called as a spin. Similarly, electrons are revolving around a nucleus as well as they have their own axis and they are rotating around that. So electron can rotate in a clockwise direction or it can also rotate in a anti-clockwise direction. So we are having two types of spin. One is plus half and another is minus half. The plus half represent the spin of electron in clockwise direction, while s minus half represent the anti-clockwise spin. ठीक है ना. तो प्लस हाफ एंड माइनस हाफ. प्लस हाफ इज जनरली रिप्रेजेंटिंग क्लॉकवाइज and the minus half is representing anti-clockwise spin. However, it is not mandatory. Plus half can also represent the anti-clockwise. Minus half can also represent the clockwise. But in general, plus half we say that it is representing the clockwise, and minus half we generally say that it is representing the anti-clockwise spin of the electron. ठीक है, चलिए तो this is what we have discussed about spin quantum number. ठीक है, चलिए तो let's do some questions on this. ठीक है, so this is the question in front of us. We have given the quantum numbers, we have given the quantum numbers, we have given the orbital. Okay, so can you let me know which one is representing which one? So here n is equal to 2, right? N is equal to 2, L is equal to 1. So n is equal to 2, so second shell L is equal to 1 is representing P. So A is representing 2P. A is representing what? 2P. Okay. What about the next one? N is equal to 3, L is equal to 2. L is equal to 2 means D. So 3D, it is representing 3D. Next, n is equal to 3, L is equal to 0. So L is equal to 0 means S. So 3S. 3S is second option. Okay. Next, n is equal to 2, L is equal to 0. L is equal to 0 बोले तो S. So 2S. Right. So first one. Right. Now you can let me know the answer, correct answer. Okay. So A is going to match with third, fourth, and second first. ठीक है, third, fourth, and second first. So option number 1 is correct. Really very simple question. This belongs to the NEET. This came in NEET 2024. Okay, fine. Next question we have is this one. We have 5dz square. We have 5dz square, and they are asking about the NLM, principal quantum number, Zimuthal quantum number, and magnetic quantum number. They are asking for the 5dz square. Now it's very easy to calculate phi. What is phi? N is equal to 5. 5 is representing the shell. D subshell. D subshell means L is equal to, and D Z square. I have told Z square, for the Z square M value is what? M value is 0. Okay. So N value is 5, L value is 2, and M value is 0. Okay. Chale. Okay. Great. Now let's come to our next part, which is called as electronic configuration. है ना? Electronic configuration. So based upon the quantum number, we can write down the electronic configuration. Okay? Based upon the quantum number, we can write down the electronic configuration. Okay? So when we are having the different subshells, है ना? जैसे for example, in this particular question, you can see, in this particular question, you can see 2s, 3s, 2p, 3d. They are representing the different subshell, isn't it? So they are representing a different subshell. If you arrange, the subshell in increasing order of their energy, if you write down the the increasing order of energy of different subshell, in them we will be filling the electron. So let's write down the increasing order of energy of different subshell. So we are having 1s, 2s, 2p, 3s, 3p, 4s, 3d. ठीक है, so 1s, 2s, 2p, 3s, 3p, 4s, 3d, 4p, 5s, 4d, 5p, and so on. ठीक है, so here you will be having the increasing order of energy. This is the increasing order of energy. In this increasing order of energy, we are going to fill the electrons. We are going to fill the electrons. Now, let's also talk about maximum number of electrons. Maximum number of electrons. Maximum number of electrons in the S can be 2. Maximum number of electron in the P can be 6. Maximum number of electron in the D can be 10. Maximum number of electron in the F can be 14. Right? So we are having these number of electrons. These are representing the maximum number of electrons in a particular substance. Chale, okay, so now we can easily write the electronic configuration based upon that. So let's take the example. Suppose I want to write down the electronic configuration for magnesium. So magnesium we have, है ना? So let's talk about the magnesium. Atomic number is 12. So we have to fill the 12 electrons. We have to fill the 12 electrons. So 1s, 2s, 2p, 3s. In the 1s, maximum 2 electrons. In the 2s, maximum 2 electrons. In the 2p, maximum 6 electrons. So 10 electrons, and now we can fill the 2 electrons in the 3s. Also, let's talk about the scandium. In this scandium, the atomic number which we have is 21. So 21 electrons has to be filled. So 1s, 2s, 2p, 3s, 3p, 4s, 3d. So let's talk about it. 21 electrons. So 2 electrons here. 2, 6, 2, 6, 2 and 1. Now you add up. 2 plus 2 plus 6, 10. 2, 6, 2, 10. So 10 and 10, 10 and 10, 20, 20 plus 1, 21. Right? So we can fill the electrons like this. Okay. So let's also talk about some more electronic configuration. So it will be easier for you when you write down the electronic configuration. Now we are having 1s, 2s, 2p, 3s, 3p, 4s, 3d. Okay. Okay. So 26 electron has to be filled. So here 2, 2, 6, 10, 2, 6, 2. Again 10. So 10 plus 10, 20. Now how many electrons are remaining? 6. Okay. So let me tell you zinc also. Zinc 30. How to write down the electronic configuration? 1s, 2s, 2p, 3s, 3p, 4s, 3d. Right? So 2, 2, 6, 10 electrons. 2, 6, 2, 10 electrons. So 10 plus 10, 20. Now we have to fill 10 electrons more. We can put 10 electrons in the 3D. So this is how we are going to write the electronic configuration, which is very easy. Now let's also talk about the exceptions. Exceptions in the electronic configuration. Okay, exceptions. So let's talk about the exceptions. Okay. If we talk about the chromium is 24. Its electronic configuration should be 1s2, 2s2, 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d4. This must be the electronic configuration. But actually, this electronic configuration is wrong. The right one is 1s2, 2s2, 2p6, 3s2, 3p6, 4s1 and 3d5. This one is correct one. This one is correct one. This is the correct electronic configuration. Okay. Why it is correct? Because here you see the 3d5. In the 3d5 you see 5 electrons are there, and 5 electrons are more symmetrical compared to compared to 4 electrons in the 3D. So this is more symmetrical. This is more symmetrical also. This is having more exchange energy. This is having what? More exchange energy compared to the 3D4. So more exchange energy. So due to these two reasons, the 3D5 is considered as more stable. ठीक है? 3D5 is considered as more stable. ठीक है? Let me tell you also one more thing in this. Instead of writing this bigger, instead of writing this bigger form, you can also write down like this: argon for S1 3D. You can also write like this. Okay, fine. Now let's talk about the next exception, which is copper. So copper 29. So for the copper, we are having 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 4s2, 3d9. This should be the electronic configuration, but in actuality, this is not correct. This is wrong. This is not correct. This is what? Wrong. Okay? And if it is a wrong, then which one is the correct? We are going to see. So 1s2, 2s2, 2p6, 3s2, 3p6, 4s1, 3d10. This one is considered as more correct. The reason is again same as previous one. If we talk about the 3d9, if we talk about the 3d9, in the 3d9 we don't have that much symmetry, while here when you see the 3d10, in the 3d10, in the 3d10, what will be happening is you will be seeing the more symmetry. You will be seeing the more symmetry. Okay, it will also be having more exchange energy, more exchange energy. ठीक है, it will be having more exchange energy. ठीक है, so this is what we saw about the electronic configuration. Let me tell you a little bit one more thing. ठीक है ना, that is this electronic configuration can also be can also be written in this fashion. We are having the argon for S1 and 3D. So we can also write like this. Okay, in the short form. Chali, okay, so this is enough talking about our chapter, which is structure of atom. Okay, now we are going to talk about our next chapter, which is called as redox reactions, है ना? So we are going to discuss about redox reaction and redox. You little bit you know about the redox. What we discuss in this particular chapter, right? So let me give you a brief introduction of this particular chapter. In the redox reaction chapter, we discuss about reduction reaction. We discuss about reduction reaction. We also discuss about oxidation reaction, right? So in this chapter basically we discuss about the reduction and oxidation reactions. Okay, so those reactions in which reduction and oxidation occurs simultaneously, those reactions in which oxidation and reduction occur simultaneously are called as redox reaction. Okay, now in this chapter we not only discuss about redox reaction, we also discuss about the oxidation number, we also discuss about oxidation state. So let's talk about this oxidation state. Let's have the discussion on this particular topic. तो चलो आओ बात करते हैं. Let's figure it out what is going to happen in the oxidation number. ठीक है, तो let's get a basic idea of the oxidation number. Suppose you are having the HCl. ठीक है, suppose you are having the HCl, right? You already know there is a covalent bond between the HCl. Suppose this were the ionic bond. Suppose this were the ionic bond. So more electronegative chlorine will be taking. Let's suppose if you are having this covalent bond as a ionic bond. If this bond were ionic bond, then what would have happened? The chlorine must have taken the electron of this bond. It will be minus, while hydrogen will be what? Plus. So suppose if you consider, if you assume that covalent bond is a ionic bond, due to the ionic bond, you will be having the formation of ions. In the ions, you see the charge. These charge plus and minus. These charge are considered as what? Oxidation. So oxidation number of Cl is minus 1. And number oxidation number of hydrogen is what? Okay. So when you break something into the ions, you can easily calculate the oxidation number. Okay. So let's talk about them. Let's talk about the other things as well. We are having the examples. देखिए HCl just now we have discussed, again we are discussing. So here you see Cl is in the HCl, Cl is more electronegative. Cl is what? More electronegative. So if you break this bond hypothetically, then Cl is going to take the electron. Cl will be minus 1, and if hydrogen is going to lose the electron, hydrogen will be getting plus. So minus 1 and plus 1 are the oxidation number. Oxidation number, or you can say oxidation state. So for the hydrogen it is plus 1, and oxidation number of Cl is going to be what? Minus 1. Chaliye, now let's take the next example, H2O. So H2O is like this. You all know oxygen is more electronegative, hydrogen is less electronegative. So if you break this bond, oxygen is more electronegative, hydrogen is less electronegative. So oxygen will be getting minus 1 due to this bond, and hydrogen will be getting plus 1 due to this particular bond. Now again we are going to break the bond. And when we break the bond, oxygen hydrogen bond we are going to break. So hydrogen will be what? Plus 1. And oxygen will be what? Minus 1. Right? Because oxygen is more electronegative, so it is going to get the electron, thus minus 1. Hydrogen is going to lose the electron, thus it is plus. अब बताइए, what will be the oxidation number of hydrogen? Each hydrogen is plus 1. ऑक्सीजन की अगर हम बात करें, तो ऑक्सीजन will be having minus 1 and minus 1. So oxidation number of oxygen will be minus 1, which is definitely minus 2. Correct. Let's talk about the H2SO4. H2SO4. So H2SO4, HOS double bond O, single bond oxygen hydrogen. Now I am going to break the bond. Oxygen hydrogen, who is more electronegative? Hydrogen. Sorry, oxygen. So oxygen will be getting minus and hydrogen will be. Similarly, if I break this bond, hydrogen is less electronegative, oxygen is more electronegative. So hydrogen will be plus 1 and oxygen will be minus 1. If we talk about this sulfur oxygen bond, oxygen is more electronegative, and here you have the two bonds, double bond. If you break the double bond, then the one which is having more electronegativity will be getting the minus 2. Sulfur will be getting plus. Similarly, here you are breaking the two bonds, so oxygen will be minus 2 and here sulfur will be plus. ठीक है, चलिए next, oxygen and sulfur. So oxygen and sulfur. Oxygen is more electronegative. So due to the single bond, oxygen will be getting minus 1 and sulfur is going to get the plus. Similarly, if you break this sulfur oxygen bond, oxygen is more electronegative, so minus 1, sulfur will be getting plus 1. Now let's conclude. Now let's conclude all these things. So hydrogen, oxidation number of hydrogen. Okay. So what is the oxidation number? Plus one, everywhere plus one. Oxidation number of oxygen. Okay. Here -2, here -1 and -1, -1 and -1, -2, -1 and -1, -2, -2, -2. So each oxygen is having -2 oxidation state. Now oxidation number of sulfur. Sulfur देखिए कितना है, +1 +1 +2 +2, +1 +1 +2 +2 +6. So oxidation state of sulfur is +6. ठीक है. Let's talk about one very good example. Let me tell you one more good example. That is Br3O8. So in this we have to tell the oxidation state, oxidation number of each bromine. So for that we have to draw the structure. So let's draw the structure. Br single bond, Br single bond, Br. Then double bond oxygen, double bond oxygen, double bond oxygen. ठीक है, डबल बॉन्ड ऑक्सीजन. ठीक है, डबल बॉन्ड ऑक्सीजन, double bond oxygen, double bond oxygen, and double bond oxygen. So this is the structure of Br3O2. Now it's time to calculate the oxidation number. देखिए, double bond is there, double bond is there. If you break, oxygen is more electronegative, bromine is less electronegative. So -2 +2. ठीक है. Similarly, if you break this bond, -2 plus, if you break this bond, -2 plus 2. If you break this bond, -2 plus 2. Similarly, double bond you break, more electronegative -2, less electronegative plus 2. If you break this bond, -2 and plus. Similarly, if you break these two bonds, break it, -2 plus 2. If you break this bond, -2 plus. Now Br, same electronegativity, so even if you break this bond, nothing will happen. Br, same electronegativity, so even if you break the bond, nothing will happen. Okay, fine. Because of same electronegativity, nothing is going to happen. Now let's talk about the oxidation number. Let's conclude all these. Okay. So oxidation number of oxygen, let's talk about. So here -2 -2 -2 -2 -2 -2 -2 -2. ठीक है, everywhere it is -2. But if we talk about oxidation number of bromine, देखिएगा, here +2 +2 +2 +2, so +2 +2. Here when you see +2 +2 +2, what is the oxidation number? Plus. Here +2 +2 +2, so oxidation number is going to be +6. ठीक है, +6. So ultimately we are having two bromine which are having +6 oxidation number, +6 oxidation number, while one bromine atom is having +4 oxidation. Right? So this is how we can do the questions based upon the structure. Based upon the structure, we are calculating the oxidation. Correct? Chali, okay. Now let's come to our next question. Okay. In which of the following, in which of the following, in which of the following compounds chlorine has +3 oxidation state? +3 oxidation state. In which of the following the chlorine has +3 oxidation state? तो आप देखेंगे, here you have the HCl. HCl we have already discussed. Cl will be -1, hydrogen will be +1. So Cl is not +3 here. अब HClO4 देखिए, how to calculate the HClO4? It is the matter of discussion. So what we are going to do is, we assume chlorine as a X. We consider chlorine as a X. Hydrogen is +1. Oxygen is generally -2 oxidation state. So hydrogen is +1 plus chlorine X plus oxygen 4. Each oxygen is -2 is equal to, so 1 plus x minus 8 is equal to 0. Here x will be equal to +1. So here oxidation state is +1. Now let's talk about the next case, which is ICl. In the ICl, Cl is more electronegative. That's why if you break the bond, Cl is -1. Iodine will be +1. Okay. चलिए next let's talk about ClF3. So consider X for the Cl. Each fluorine is always having -1 oxidation state in its compound. X -1. Okay. So X plus 3 fluorine. Each fluorine is -1 is equal to 0. So X minus 3, X minus 3 x minus 3 will be equal to what? So ultimately from this we got x is equal to. So by assuming x also we can calculate the oxidation number. Chaliye, so answer +3 of chlorine is present in option number 3. Okay. So we are having the two ways to calculate. We are having the two way to calculate oxidation number, oxidation state. The first one is by making the structure, and the another one is assuming x. So these are the two ways, but in them also the more accurate one is the by making the structure. Okay. So by making the structure, the oxidation number will be calculated and that will be assumed as a more correct. Chali, okay. Now let's come to our next topic, which is balancing of redox reaction. Okay. Next topic which we are going to discuss is about balancing of redox reaction. Okay. And in the balancing we are going to discuss about the half reaction method. Okay. What we are going to discuss? We are going to discuss about half reaction method. Half reaction, as the name suggests, half reaction method means we are going to divide the equation. We are going to divide the equation into two equal half. We are going to divide the reaction into two half reaction. These two half reactions will be, one will be oxidation reaction, another is going to be the reduction reaction. So oxidation and reduction, two of the reactions are going to be there, and we are going to separate a single reaction into two half reactions. Okay. But before discussing about the balancing, let's talk about one more thing, which is which is which is if I talk about the general law, general phenomena, general balancing. So first thing what you do is, in this half reaction method, the first thing which you are going to do is, the first thing you will be doing is balancing the element. You will be balancing elements in the half reaction method. Half reaction method, in the half reaction method, you are going to balance the, you will be balancing the elements first. Okay. Elements other than other than elements which are other than oxygen and hydrogen. So you will be balancing the elements which are other than oxygen and hydrogen. So first you will be balancing the elements, right? don't balance the oxygen and hydrogen, because oxygen and hydrogen will be balanced late. Second way is oxygen is balanced by oxygen is balanced by oxygen is balanced by oxygen is balanced by water. Oxygen is balanced by water. Third is third is third is hydrogen is balanced by hydrogen is balanced by hydrogen is balanced by H plus in the acidic medium. Hydrogen is balanced by H plus in the acidic medium. And the fourth and last option is charge is charge is balanced charge is balanced by electron. Charge is balanced by what? Electron. Okay. So electrons will be used to balance the charge. So these are the four important points which we have discussed here and which we are going to use in the balancing of the upcoming reaction. Okay. So in the upcoming reaction, we are going to see the balancing because of these. We are going to follow these four steps. Okay, fine. So let's talk about this reaction. So in this reaction, let's calculate the oxidation number of each element. Here when we talk about the manganese is having the oxidation number which is +7. And here oxidation state of the manganese is what? +6. Oxidation state of iodine is -1. Oxidation state of I2 is what? 0. So here you can see the two reactions, correct? Two reactions. What are these reactions? देखिए I minus to 0, I minus to 0, so there is a increase in oxidation number. If there is an increase in oxidation number increases in this reaction, that's why it is the oxidation reaction. This is the oxidation reaction, correct? Now when we look at the next reaction, when we look at this next reaction, in this next reaction, you see the +7 is converting into what? Plus 2. So when +7 is converting into +2, you can see there is a decrease in oxidation number. There is decrease in the oxidation number. When you decrease the oxidation number, that reaction is called as reduction reaction. So now what we are going to do is we are going to write. Now we have decided two of the reaction. One is oxidation reaction and another one is the reduction reaction. Now we are going to separate these two equations. So let's separate these two equations. The first equation which we are going to write is oxidation reaction. So let's write down the oxidation reaction. Okay, so oxidation reaction. So we are having the oxidation reaction I minus is converting into I, correct? This is the oxidation reaction. What I told you is here we have the iodine, so let's balance this equation. So how many iodine atom you see here? 2. So this side also we should have 2 iodine atoms. So 2I, here 2I. Now charge is balanced by electron. So charge is balanced by electron. Here we don't have oxygen and hydrogen. If we don't have oxygen and hydrogen, then why to balance them? There's no need. Now let's talk about the next part of this particular thing, which is the reduction reaction. Which is the reduction reaction. Okay? So reduction reaction. Reduction. So we are going to do the reduction. Okay, na? So let's talk about the reduction part. Reduction part, in that we are having MnO4 minus plus. Sorry, MnO4 minus converting into Mn plus 2. Now, how many Mn this side? 1. How many Mn this side? Again, 1. So 1 and 1. So manganese element is balanced. The element other than the oxygen and hydrogen is balanced. Manganese is balanced. Now, what we have to balance? We have to balance the oxygen, right? As I told you, oxygen is balanced by water. Oxygen is balanced by water molecules. Here we are having 4 oxygen, so we are going to add 4 water molecules. We are going to add 4 water molecules in the right side. Okay, so we have added 4 water molecules in the right side. Correct? Okay, great. Now 4 oxygen this side, 4 oxygen this side. Now the next thing, hydrogen is balanced by H plus. Hydrogen is balanced by H plus. So 4 into 2, how many H plus? 4 into 2, how many H plus? 4 into 2, 4 into 2, 8 hydrogen atom. 8 hydrogen atom are there, has to be balanced by H plus. So 8 hydrogens are there. That's why we are going to put 8 H plus this side. We are going to put 8 H plus this side. Correct. Now I told that charge will be balanced by, charge has to be balanced. Now everything is balanced. Charge has to be balanced. देखिए charge कितना है? What is the charge? How much is the charge? -1 is there. 8 into +1, you have +8 charge. The total charge this side is +7. When you look at this side, you are having the total charge is what? +2. So +7 that side, +7 that side, +2 this side. So we are having, we have to balance this charge with the help of electrons. So what I am going to do is, I am going to put 5 electrons in the left side. If I add the 5 electrons left side, so 5 into -1, so we will be having -5. 5 into -1, -5. So -5 is there, -5 is there. So you will be having +2 charge in the left hand side. Correct. So +2 charge in the left hand side. Correct. Okay. So +2 same. So everything is balanced. You can check. So now we have balanced the two equations. We have balanced the two equations separately, oxidation and reduction. Now we are going to combine them. Whenever we combine them, whenever we combine them, we have to cancel out the electron. What I told, whenever we combine the reaction, we have to cancel out the electrons. Why we have to cancel out the electrons? Because the number of electrons are lost in the oxidation reactions are gained in the reduction reaction. The number of electrons are lost. Number of electrons are lost in the oxidation reaction must be gained in the reduction reaction. So there is overall there will not be any electrons. So we have to cancel out the electrons. So in order to cancel out the electron, what we are going to do is, we are going to multiply this equation by 5. Multiply that with 5, and here I am going to multiply this equation with 2. अब देखिए why I have done so, because 5 into 2 10 electron, 5 into 2 10 electron in the right side, and 5 into 2 10 electron in the left side. So when you combine them, 10 10 electron, 10 electron will cancel out with each other. ठीक है, चलिए, okay. Now I am going to write down, the final equation. I'm going to combine both of these two equations. So let's talk about it. So 2 into MnO4 minus, so 2MnO4 minus, ठीक है, plus I am going to write this one 5 into 2, 5 into 2, so 10I minus, ठीक. Then I am going to write 8 into 2, 8 into 2, so we will be having 16H plus, 16H plus. Then 2 into Mn plus 2, so I am going to write 2Mn plus 2, 2Mn plus 2, ठीक है. Then I am going to write I2, So for the I2, 5 into I2. So 5 into I2, 5 into I2 plus 5 into I2 plus, देखिए this side 2 into 4, 8 H2O. So we will be having we will be having 8 H2O. Now you check. Now you check complete reaction and tell me whether everything is balanced or not. You can take your 1 to 2 minutes. Okay, check everything and let me know whether everything is balanced or not. Yes, everything is balanced. Let me help you out. 2 Mn, 2 Mn, 2 Mn. Oxygen, 2 into 4, 8 oxygen. 8 into 1, 8 oxygen. Iodine, 10I. Yes, 10I. 5 into 2, 10I. Okay, correct. H, how many H? 16H. 8 into 2, 16H. Right, the hydrogen is also balanced. Charge, take it charge. 2 into minus 1, minus 2 charge. 10 into minus 1, minus 10 charge. 16 into plus 1, how much charge? Plus 16. So here when you sum it up, you will be getting 4 plus in the left side. 4 plus charge in the left hand side. What about the right side? 2 into plus 2. Right side we have plus. So charge is also balanced. Right? So everything is balanced here. Charge is balanced. Elements are balanced. So overall this reaction is what? Balanced. Right? So this is what we have discussed. This is what we have discussed. Balancing of redox reaction. Balancing of what? Redox reaction. Balancing of redox reaction with the help of half reactions. Okay? Chali, okay. So what we have discussed in today's session, let's quickly recap that and then we are going to wind up this session. So in this complete revision, we have discussed about 3 chapters. The first one was some basic concepts of chemistry. Second one was structure of atom. The third chapter was redox reaction. Okay. The first chapter we have discussed the moles, calculation of moles with the help of number of particles, calculation of moles with the help of mass, calculation of moles with the help of volume. Okay, we have done uh, questions, we have taken the examples on them, and I hope you understood what we have done so far, right? And after that we have calculated, we have seen some more good level of question in which there was the use of moles. Then second thing which we discussed was the stoichiometry. In the stoichiometry, we have seen a very good formula. From them, you can calculate the number of moles, and later on, those moles can be used to calculate the mass, calculate the volume, calculate the number of particles, right? That we saw in the stoichiometry. After that, in the stoichiometry, we have seen the limiting reagent, right? We have discussed that limiting reagent limits the amount of product, right? Limiting reagent is very important. Whenever you have to form the product, you have to form the product based upon the limiting reagent, and you must know how to calculate the limiting reagent, right? So limiting reagent, identification of limiting reagent is quite important, which we saw with the help of limiting reagent ratio. That was moles upon a stoichiometric coefficient, right? So remember how we have got to know the limiting reagent. Correct. So this is what we have discussed in the some basic concepts of chemistry. Then we discuss about the structure of atom. In that, we have discussed again many of the things. Very important model we discussed, which was the Bohr model. In that, we have calculated the velocity of electron in a particular orbit. We have also discussed the radius of particular orbit. We have also discussed the electron energy, energy of electron in a particular orbit, right? ठीक है ना? So this is what we have discussed in that particular chapter. ठीक है ना? Formula you must remember, don't forget the formula, because whenever question come in the NEET, that is from the formula itself, right? There's no much tricky question, but directly formula, but directly based upon the formula, right? So you should remember the formula at least, so that you can do the questions very quickly, right? Okay. Then after we discuss about the quantum numbers are quite important, because on the quantum numbers also questions are coming. In general, it is coming everywhere. If not everywhere, then every year it is sometimes coming alternative. Nowadays, generally, the question is coming in NEET from the quantum numbers very often. So you must understand the concept very carefully, and then you can proceed to the question. Questions are very simple based upon this quantum numbers. So you should have the basic understanding of the quantum numbers, and then you can go to the advanced level if you want. Okay, we have also seen the questions which already came in the NEET, and those were quite simple if you know the concept, right? Fine. Then after we have seen the electronic configuration. In the electronic configuration, what are the exceptions are there? So we have discussed that chromium is an exception, copper is an exception, right? So why they are exceptions, we have also discussed, correct? Chali, okay. Then we have moved to our next thing, which was our redox reaction. In the redox reactions, we have seen how to calculate the oxidation number. After the calculation of oxidation number, we have done the balancing part, right? Balancing of the reactions with the help of half reaction, correct? So with the help of half reaction, we have divided the reactions into two equal half, two half, which is oxidation reaction and reduction reaction. Okay, and then we have clubbed those reaction after balancing each reaction. Okay, chali, okay. So this is all from my side. This is all from my side. This question you can take. This question I am giving you in the homework. And please note it down, and you can solve in the homework, right? Okay. Okay, so that's it for today. That is for that is uh, that is from my side. Okay. Thank you all of you. Thank you very much. I hope you enjoyed the class, and very happy to see that many of the students have joined the class and they have enjoyed the class. Thank you. Thank you very much. Thank you all of you.